Previously in the fundamentals tutorials we revolved a curve to create the side glass. But this time I want to look at specifically working from mesh data. And for this we've got a side glass option in the revolve tool. And the first option, which is barrel, doesn't use a curve, so I'll just delete this one. So the side glass setting has two options, and I'll start with barrel. And this requires 5 points to be selected on the mesh. And the first 3 are creating the arc of the side glass that rolls down into the door. And I don't need to curve snap because it automatically picks on the mesh. And then this point here will get reused, and then these 2 points create the large arc along the side. And that's now created the revolved surface. And it still creates the axis for me that I can extract or reuse. But we're controlling it right on this side glass mesh, which is much more intuitive. So let's put on some cross sections and see how well it's matched the scan. And that's pretty good. It's really close where I specified the points, and there's a small amount of deviation near the front. Now, having specified the points on the scan data, I can still extend the surface using these blue arrow manipulators. And I can also modify any of the original points to get a better fit. So if you have a good scan of a side glass, then the barrel tool works really well. The other option is Helix, and I just want to use this simple example here to show you how it works. And I'll go back to a normal freeform revolve to show you the pitch setting. And this offsets the revolve along the axis, which creates a helix shape. So I can increase the sweep to a really large number, and then just increase the number of spans so that it can follow the shape. And then I get a spring or a coil. And now changing the pitch just compresses or expands that spring. So let's see how that might work on a side glass mesh. So I'll choose the helix option, and this one does require a curve, so I'll just make that visible. So this could be a true arc or a freeform curve, but you still want it to roll up and down a true arc. So I'll accept the curve and then click 2 points either side to specify the arc of revolution. And again it creates a feasible revolved surface and an axis line. So let's just apply the cross sections and see what we've got. And again that's quite close in the middle, but it deviates a little bit at the front and the back. But it's called a helix because I can change this pitch value. And we can see how that works in this side view. So if I now change that pitch to a negative value, it twists in the other direction. So I can play around with that setting until I match the mesh more closely. And I can still extend it if I need to with these blue arrows. So it's just an alternative method to the barrel that allows for a helical twist while maintaining the engineering feasibility.